Okay, good afternoon. We actually continue the lesson. We started talking about the graph of trigonometric functions. So if you remember, we talked about what happens if I give you the graph of this function, for example, and then ask you what will be the graph of the function if I multiply it by a number, say a. And then I ask the same question and asking you what will happen if I just multiply the x by a number, say for example b. So I don't know how much you remember. So if the graph of this function is given to you and you multiply it by a positive number here, so what will happen? The original graph will be stretched or squeezed along the y direction depending on the magnitude of the number a that you are multiplying the function by, yes? If a, of course, if a is 1, nothing will change. That would be the same function. But if a is greater than 1, then the graph will be stretched. For example, if this is 2, you will have the same version of the graph, but stretched 2 times along the y direction. And if I multiply it by 1/2, that is stretching by 1/2 means squeezing it 2 times, yes? So that was the effect of multiplying a function by a number. So the effect will be along the y direction. Nothing will be changed along the x direction. Okay? And then you remember what will happen here? If I multiply the x by a number, not the whole function. So what was that? What was the effect of that? Yes? It will be either again stretched or squeezed, but this time along the x direction. But there was also a vital important difference between these two cases. What was that? In this case, if my number is bigger than 1, the graph will be stretched. But in this case, if b is between 0, if b is greater than 1, the graph will be squeezed. Okay, so that was a little bit counterintuitive. So the x direction is always counterintuitive, especially today's lesson. You will see the same situation here. So is that clear? So that was a summary that we had before. So what you need to remember for this course, for this lesson, is the graph of a standard sine and cosine function, and try to find the graph of the new functions. For example, if I give you this, in principle, you need to have a good idea of how the graph of this looks like. And then I can ask you, what is the graph of 2 sine x? Okay, so you should be able to understand the connection between these two. Or I might ask you, what is the graph of sine 3x? So, do you remember that this will actually change the period of this function in that case? Yes. So we had also a formula for the period. What was the period? It was 2 pi divided by this number that you write here, or 360 degrees divided by pi. So if I give you y equals to a sine bx, and if I give you y equals to a cosine bx, the amplitude of these two functions is this number a, but the period of these two functions are the same, and it follows this rule, which of course is given in the formula sheet. Yes? Today we want to continue the same kind of lesson, but instead of multiplying, I want to add a number to them. Okay, so my question is that, still this graph is given to you, what will happen if I take that graph and add a number to it? Okay? And I want to answer the same question if I do the same thing with x. I take x and add a number to it. So I want to understand how the graph will be affected under these two changes. Okay? And then of course we can combine all these 4 into one single formula. I can multiply the function, I can multiply the x value, I can add a number to function, I can add a number to x simultaneously. Okay? Okay, I think this is easy to understand it from a very simple point of view. Okay, so let me just forget about trigonometry for the time being, because whatever I told you here, it was completely generic. You can also apply it for any kind of function. So let me start with a very famous function, a very simple one. So y is equal to x squared. Okay, let us see what will happen. So if you don't mind, let me set up a table here. We can also go to GeoGebra to make it better, but here let us understand what is going on. So let me just give three numbers, -1, 0, and 1, to draw this graph. This is x squared. If I put -1 here, it becomes 1. If I put 0 here, it becomes 0. If I put 1, it becomes 1 again. So if you want to draw the graph of this function, you set up a table, you set up a coordinate system, for example, x and y. So let us see what happens here. X minus 1, y is 1. So -1 here, 1 is here, so that's a point. And then 0 and 0, that's another point. And then 1 and 1, that's another point, yes? And of course, you know what the graph looks like. Something like this. This is y equals to x squared. Okay, now let us see what happens. For example, let me make it simple. What happens if I add 1 unit to y? So I have my function is finished here. I add a number to the whole function. Okay, so what will happen here? It's easy to understand, yes? Nothing will change from x point of view, but the y values will be 1 unit more, yes? So it means that if x is -1, x squared is still 1, but now I am interested in x squared plus 1, so the value will be 2. And then if x is 0, I put it here. This time the value becomes 1. When I put 1 here, the value becomes 2. So if I ask you what is happening, you can see that the x values are not affected, but each y value is 1 unit more than the corresponding older value. So what happens? It means that x's remain the same, but y's will actually shift 1 unit above. Yes. So if I want to draw the graph, -1 and 2, this is -1, but not 1. This time 2 is here. 0 and 1 is here, and 1 and 2 is again here. Okay, this is not a very good picture, but you can understand what is going on. Then I just draw the graph. So I hope that you agree with me. Of course, this is not a good picture, but you can feel what is going to happen. Assume that this black curve is a rigid object. It seems that you are taking that rigid object and shift it 1 unit upward, yes? So that is the effect of adding a number. So it's extremely simple. No effect, you will not see any effect on the along the x direction. You will see the effect along the y direction. And what do you guess if I, for example, add +2, what will happen instead of +1? It will be shifted 2 units. If I add a negative number, what will happen? x2 -1. It will go, for example, down, yes? So it is also intuitively clear. So if you add a number to a function, it will go up. If you subtract a number from your function, it will go down, okay? Without nothing changed. Is that clear? But for the other case, let me, for example, instead of adding 1 to the function, let me add 1 to x value. So what does it mean? It means that I have x to power 2, but let me add 1 to x value. Yes? And see what happens. Okay, here this will affect the x values. Of course, these are just sample x values. I have to consider all possible values, okay? But my goal is to tell you something else. Of course, I have to consider all values, but intentionally, let me ask you this question. In the previous case, in the original case, if I want to reach height 1, there are two options. Either I have to choose x to be -1 or I have to choose x to be 1. In both cases, the y value reaches the height 1. Yes? And if I want to reach height 0, I have to choose x to be 0. Now, answer this question for this one is simpler. If I want in the new situation, if I want to reach to the same 0 height, what value I have to choose for x in this function? I want the output becomes 0 as before. In the previous case, I have to choose 0 for x to be able to get 0. But in this new function, yes, I have to put -1. So let me start with -1 here. If I put -1, this -1 is different from this number, but I will reach to the same y value. Okay? Now tell me, if I want to get 1 in this new setup, what should I choose for x? 2 values. One value is, tell me, I want to reach to the same height 1 in the new setup. Yes, Jose? 1 is 0. Yes, so I put 0. If I put 0, I get what? 1. That's correct. There is another number. Yes, what is? -2. Okay? So you see, my goal was to keep the y values the same. I have to adjust myself with the x values to be able to get the same y values. Okay? And now let us draw the graph here with a different color. So it's -2 and 1. So in order to reach to height to height 1, I should be here on -2 and 0. So -2 is here, 1 is here. This is 1 point. -1 and 0. -1 and 0 is another point. And then 0 and 1 is this point. So, and then if you draw the graph here, so what is happening? I hope that you agree this green one is a carbon copy of the black one, except that it is shifted along x direction this time, but it's counterintuitive, yes? Because you are adding a number, you might expect that the shift is towards the right side, but no, the shift is towards the left side. It is counterintuitive in the beginning, but this is reasonable, because in order to reach to this height, in the previous case, you have to wait until you reach to 0. But in the new case, because I am adding 1 unit to x, I reach to that number earlier. Yes? So this is why it is shifted towards the left. So that's the whole lesson today, actually. But of course, I will solve this one, which is harder. Question. I will come back to the trigonometric functions. Is that clear? So, now I hope that you understand. If I add a number to a function, the graph will go upwards. If I add a negative number to a function, the graph will go downwards, exactly with the same amount of the number that I am adding or subtracting. But if I add a number to x value, it will go to the left with the same amount. But if I subtract the value, what do you expect? If instead of having x plus 1 squared, if I have x minus 1 squared, then it will be shifted 1 unit to the right for the same reason. Because then it will be delayed a little bit, yes? Because whatever you had before, you have to wait a little bit more to reach to that height. Okay, but this might be confusing. Let me ask you this question. If I ask you how much shift you see here from the original graph, it is 1 unit to the left. This is important, I want you to understand. If I just write this, how much is the shift? So here, how much is added to x? Yes. It's 1/2. But with respect to which graph, that's also another story. Yes? So I want you to understand this. Because I told you that this 1 is not added to x. It is added to the whole combination 2x. So this is not amount of shift, because the amount of shift is the number which is added to x itself. Okay? So now this is clear that this 1 is not the real shift, because 1 is not added to x itself, it is added to 2x. Now if I ask you how much is added to x itself, how do you answer that? So you need to do a little bit of simple algebra, yes? You take 2 out, and then you write x plus what? What should I write here? So 1 over 2. Yes? Because when I multiply it back, I get the same thing. But let me now raise it to power 2. This 2 becomes 4, and then this becomes x plus 1/2 to the power of 2. Okay, so the amount that is added to x is what? As Matthias said, is 1/2. But you cannot compare this graph with the graph that I told you here, because they are not the same thing. If I change x to x plus 1/2 here, I will get this. Yes? So if I ask you, do you know the graph of this? The answer is yes. The graph is the carbon copy of the graph here, except this is shifted 1 unit, 1 over 2 to the left. But the graph of this function, you shouldn't compare. If I ask you what is the graph of this function, you do this simple algebra, then you realize that you shouldn't compare this graph with the original graph that I wrote here. You have to compare it with which graph? 4x squared, yes? So if you have this graph, the graph of this function is the same unless it is shifted 1 over 2 units to the left. So this is the only thing that you shouldn't get confused when you want to understand the amount of shift, okay? So the amount of shift on the x direction is not that number that you can see there. It's the number which is added or subtracted to x. Okay, that is the amount of shift on the x direction. Is that clear? Okay. So now, let us go back to talk about what is about trigonometric functions, which is actually the important part of the lesson today. So these are the types of functions we want to understand. A sine bx plus c plus d, and I want to have the same thing for cosine. I will not give you questions, and I haven't seen them in national exam either. They don't usually give you questions to draw the graphs from scratch, okay? But they might draw a graph and say that if this is the graph of this function, draw the graph of the other function. So you need to use that and these rules to understand how to change the graph, the given graph, to the graph that they want. Or another type of questions which is very common, they already give you the graph and they ask you, if this graph is the graph of such a function, find A, B, C, and D, which is probably the most common question. So I draw a graph for you, for example, like the one that you see here, and I ask you to find the suitable values for A, B, and C, and D, for example, so that this graph looks like the one that I have given you in the picture or image. Okay. But there are some points. I want to develop 2 more formulas. I haven't seen them in the formula sheet, but I would say this is really important to realize, or at least understand how to find them. The first thing to remember, which is in the formula sheet, is this one. Yes, it is the period. This you don't need to be worried, because this is given in the formula sheet. How can I use this to find B? By looking at the graph, you should be able to understand, to read the period on the graph. When you have that number, put it here and find your B. Okay, now I want to talk about how to find A or D. This is the formula which I don't think it is in the formula sheet. I have already uploaded the formula sheet, you can check it out. But let me ask you one question. I want you to answer that, because even if you forget the formula, using this idea, you can immediately get it. Can you tell me, for example, let us concentrate on the first one. Whatever I say about this will also be valid for this. Can you tell me what is the maximum value of y for this function? Because why I'm saying this, reading y maximum from the graph is very simple. You just look at the graph and see the highest point and read y value for the highest point. So reading y max from the graph is extremely simple. So what is the y max now? This micro. Okay, so y max, what is the value here? Yes, Abdullah? No, this is my function. A is only the maximum of this part. So you are close. What is that? Yes, Robert?
Isn't it absolute value of A plus D?
Yes, but by the way, you are completely right. We have to write absolute value. But in the book, they have chosen A always positive. And by the way, even if I give you a negative value here, asking about the amplitude, you have to remember, you have to give me the absolute value. The amplitude, by definition, is a positive number. Okay, so let us consider that A is positive. So that's good that you mentioned. Okay, so then you don't need absolute value. So you say that sine is maximally 1. Because I want to reach to the highest possible value. A and B, C, and so A and D, B and C are fixed numbers, so I cannot change them. What I can play around with is just X. So to maximize Y, I have to maximize this part. But the maximum of sine is clear. It is 1 at most. So if I put the maximum value of sine into my function, I will get the maximum value of y. Is that understandable? So even if you forget, you can immediately find it. Okay, the same question. Can you tell me what is the minimum now? What is the minimum?
D?
No. Yeah?
A plus D.
No, A plus D is maximum. So can it be maximum and minimum be the same? Unless, yes, it can possible, but you have to be on a horizontal line. Yes? Yes, minus A plus D. Because what is the minimum of sine? The minimum of sine is minus 1. If I want to make this minimum, I have to make this part minimum. What is the minimum of this part? Minus 1. So the minimum becomes minus A plus D. Yes?
But I thought you said that it has to be absolute value. Because I thought it was minus A plus D. Something about
No, I didn't say absolute value. I have written A is positive. I am asking what is the minimum.
Yeah, if A is positive, how does it become minus A?
No, A is positive. For example, A is 2. Minus A is minus 2. Yes? So minus A plus 2. Yeah? And now let us add these two together. This becomes y max plus y min is equal to what? A and A are gone, 2D. But I am looking for D. So this is the formula I told you. It's not in the formula sheet. Y max plus y min divided by 2. So it is extremely simple to calculate this because you just look at the graph, find the highest value for y, find the lowest value for y, put them in this formula, and you find D. How can I find A? How can I find A? Instead of adding them, what do I do this time? Yes?
Y max minus D.
Y max minus y min. I subtract them. Because what will happen if I subtract them? This becomes y max minus y min is equal to y max is A plus D, y min is minus A plus D. If you simplify that, and then this D and that D are gone, so it becomes 2A. So y max minus y min is 2 times A, but I want to find A, so this becomes y max minus y min divided by 2. Yes? So, These two, if you remember these formulas, or you can understand this, extremely simple. It's a matter of seconds to find A and B, A and D. B is also somehow understandable. If you can understand what is the period, you read the period from the graph, put it here, you find B. Okay, so if you want, I can write formula for B here. B is 2 pi over the period. Or if you want, by the way, this should be very familiar to you in physics, is it? What is that? 2 pi over t is the angular velocity, yes? And that is why in physics you have a sine omega t plus phi, or something like that. I don't know, you don't have phi probably.
Not yet.
Not yet, okay, anyway. But then this is not x in physics, this is time. But that's more or less the same structure, okay? So B is this one. The only problematic one is C. Okay, so you need to understand, and that when, by the way, there is no unique value for C. There are infinitely many values for C. We will see why. But let me ask you the same question that I asked there, here. Okay, if I ask you how much shift is done, because if you want to understand the graph of this function, the standard sine function we already know. Let me just draw them. By the way, you should have them in your memory somehow. The standard graph of sine x, do you remember? In one period. It starts from here, and then here is 90 degrees. So let me write everything in radians. So pi over 2, let me just draw it again. And then here is 2 pi. So the graph here goes 1, and here goes -1. So that was the standard sine function, the graph of a standard sine function. So something like this. It is extremely important to remember the sine function, the standard one starts at the origin. And then for the cosine one, what is cosine? Let me draw it the same. So the cosine one is this. Here, and then this is here. So this, the graph of the cosine one is here. Something like that. Okay, so that is cosine, and that is sine. So these are standard pictures, you should have it in your memory, something like that. Okay, and then if I ask you what is happening to this, you should be able to compare this with that one. So can you tell me what is happening? For example, you are multiplying your function by a number, so the effect will be stretching or squeezing along the y-axis. And then you are adding a number, so the effect will be shifting up or down, depending on if t is positive or negative. And then you are also doing what? You are also multiplying by a number b. The effect will be squeezing or stretching along the x direction, but opposite to your intuition, yes? And then this c is affected by, it will affect the shift. Yes, it will actually cause the shift on the x direction. So you are doing four transformations on the original graph. Yes? But anyway, can you tell me how much is the shift now? If I ask you, you know that there is a shift because something is added to the x part. But how much is the shift? If you just naively say c, it would be the same mistake as if you say 1 is the shift here. So how much is the shift in this problem, in this function, compared to this original one? Yes? It's c over b. This is important, yes? So you factor this out. So this becomes a sine. You factor this out. It becomes x plus c over b. And then, of course, plus d. And you see that how much is added to x itself? Not c. c over b. Yes? So I would say that the amount of shift along the x direction is c over b. Okay, but when I say the amount, it should be positive. So the shift, let me write just like that. The shift along the x direction is this, not c. Of course, if this number turns out to be negative at the end, the shift is to the right. If this number turns out to be positive at the end, the shift is to the left. And I really recommend you to do them in order. C, because C, in order to understand C, you need to read the amount of shift, and you need to already know B so that you can have only one unknown and find it. So it is extremely important to do this last, to find C at the very last step. Yes? Everything that I mentioned here is also the same, the formulas are exactly the same for this function as well. But this function should be compared with the red one. This function should be compared with the black one. Okay. Is that clear? Okay. Before doing this example, because the examples in the book are not exactly what I want, so this I designed it myself. But there are two good problems in the book. So if you don't mind, let us go first solve that problem, and then come back to solve this, and then we finish the lesson. Okay, so let me pause recording. Okay, so as you see, this is the problem in your book, 2328. There are two questions, okay? Well, let us solve them one by one. I want you to think, if you can solve this problem and the one that I designed, you are completely on the safe side with respect to this part. So the graph of two functions are of this form. They could have asked cosine. They are asking, no, this is sine. Okay. So they are drawn, and then you want to determine A, B, C, and D in each case. Yes? So let us, I don't know, let us work with the red one first. Okay? So forget about the blue one. Look at the red one. Assume that the blue one is not there. By looking at the blue one and information that you can see in this picture, I want you to find A, B, C, and D. So this is the type of question you expect to get in the exam, even my exam, okay? I don't know, do you want me to solve the first? Let me solve the first one myself, then you can work on the other one and the example that I want to describe. So let me just find that one. So the first thing comes to mind is to calculate A, I would prefer, and then D, and then B, and finally C, okay? For A, I have already given you a formula. So look at this picture here. So here, A is y max minus y min divided by 2. It's extremely simple to read these two pieces of information from the graph, yes? So what are those? What is the maximum value for y in the red curve?
4.
You see it is 4. And what is the minimum?
0.
0. So if I go back to the here, so I calculate A. So A is y max, which was 4, y mean divided by 2. So A is 2. As simple as that. And D also I can find it. D is y max plus y mean divided by 2. Coincident, this is a coincidence. Both of them are exactly the same values. Okay, but for B, I have to read the period. So I go back to the picture here. Can you read the period for me? So for example, do you think that if I go from here up to here, it's one period? Again, let me just draw a little bit close to it. Do you think this is one period? Oops. Okay.
No.
Do you think it's a one period? No. Yes, so that's what I'm saying. You need to have a good understanding what a period is. A period is that part of the graph. So if you take that part and copy and paste it over and over again, it will generate the graph, but minimally. Because you can make a very big portion of the graph and copy and paste it over and over again. So the period is the minimum portion of the graph. So I hope that you agree with me. If I start from here and go up to here, this becomes one period. Do you agree? Okay. So then when I understand the period, I have to read the amount of period. So this I don't know, might be you can guess with your eyes or whatever. For example, I can say from minus pi to pi is how much? From minus pi to pi, the length is 2 pi. But this is 2 grids to the right. This is also compensating 2 grids to the right. So still the period is 2 pi. This is one way of reading it. Another way, which is also useful to know, you see that 1, 2, 3, 4, 5, 6 intervals, 6 of these small grids equals to pi. So it means each grid is pi over 6. And then you will start counting the number of grids. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then you multiply 12 pi over. It's up to you. By the way, these questions, I will not ask you how to find them. I just want the final answer is required. Okay? The simplest possible way is probably to cheat. Okay? I'm joking. Okay, I mean that because the final answer is required. So that is also one way, yes, to find the answer. Okay, so we know that the period is, how much I said? Do you remember? 2 pi. Okay, so let us go back to the board. I put the formula here. Be careful, the formula in the formula sheet is the other way around, okay? But that's easy to understand that. So the B part, which I don't know, is equal to 2 pi divided by the period, which coincidentally was 2 pi again. So what is B? It's extremely simple. And if B is 1, you are completely lucky because you don't even need to bother about this part. Because if B is 1, the amount of shift is exactly C itself. Okay? So then you need to read the amount of shift going back to the picture again. So that's what I want to do now. So the amount of shift is a little bit tricky sometimes. If you are, by the way, the things that I am telling you is not the only way. If you can find your own way to understand it, just do it, okay? But this is one way I do it. Do you remember what I got for D is 2? The way that I do it, I draw, in my head at least, the horizontal line passing through 2. Passing through D, the D value. The D value is 2. So I draw this line in my head. Okay? I call it the guideline, for example. And then when I have the guideline, you immediately realize this is the amount of shift. Why? Because this is supposed to be a sine function. So I compare it with the original sine function. Yes? The original sine function, it starts at the origin. Okay? But when I say draw the guideline, I am asking you to think this is your new x-axis. Okay? This is your, this line, it's disturbing here. So this line is your new x-axis. Okay? And then what is happening? This sine function should start from the origin, but now it is starting from here. So this is the amount of shift. Is that understandable? Yes or no? Yes. Okay. So how much is the shift? 1 grid. 1 grid is your shift. And the shift is to the left. When it is to the left, what should I do? Add or subtract? Add. Because I add and I go to the left. How much I have to add? 1 grid. What was 1 grid? It was pi over 6. So that's it. So C is pi over 6. Yes? So C is pi over 6. By the way, C is not only pi over 6. Do you agree with me? Because in this problem, I don't know, for example, if you take and shift it 90 degrees to the left, this will overlap with the red one. But I can shift more, yes? Because these periodic functions go forever, yes? So this is why, this is an open question. So there are many answers that you can provide. To fix this problem might be in my exam I ask you to find the smallest positive value for C. In that case, everyone should answer the same thing. If I don't do that, for example, if one of you tell no, pi over 6, I can add pi over 6 plus 2 pi. That is also working, but you are shifting more. Yes? But you are shifting more, but because these up and downs are actually repeating themselves, you still go back to the same point. So this is not unique. But if I ask, give me the smallest positive one, or give me the smallest, the highest negative one, or something like that, then it becomes unique. So at the end, what I write for my function is what? I found a to be 2, sine. I found b to be 1, so I don't write it. I found c to be pi over 6, and then I found d to be 2. So the graph that you see is the graph of this function. Yes? Okay, the same question, I want you to think about it yourself and answer this one. The same question for the blue curve. I want to wait for you, and then I go to my question, and then we are done. I give you time to think about it. Okay, could you solve the problem? Okay, so let us go back and forth here. So first of all, you know that for finding a and d at least, I need max and mean values for y. And it is easy, very easy to read. What is the y max value? 5. And what is the y mean value? -1. Okay, so let us go back to the board. So a is equal to y max minus y mean divided by 2, which is 5 minus -1 divided by 2. The max value is 5, the mean value is -1. There is a minus sign in the formula, so this becomes 6 over 2, which is 3. So A is exactly 3. Yes? And then I do D. D is equal to y max plus y mean divided by 2, which is 5 plus -1 divided by 2. 4 divided by 2 is 2. So D is 2. Okay? For finding B, the formula, let me write the formula which is in the formula sheet. Of course, you can use that one. But let me write this formula you will find in the formula sheet, because everything is in radians. I write the radian version. So what you need to do is to read the period from the figure. So let us go back here. So what is the period? Of course, it is, by the way, to be honest, this is not logical, because you need to have access to the rest of the graph to understand the period. Yeah? So that is probably a weakness of this question, because we don't know what's happening outside. Anyway, but where is the period? The period is from here, hopefully understandable, up to here. Yes? So it goes from here, you go up and down here, up to here. So that's a period. And then you need to read what is the length of this, but it's very clear. It starts here, fortunately, from minus pi and goes up to 3 pi. So what is the period? The total length. The total length from here up to here. What is that?
4 pi.
4 pi. Okay, back to the board here now. 4 pi is equal to 2 pi divided by b. So then I switch these two, so then it becomes b is equal to 2 pi over 4 pi, and then it is 1/2. Okay, so this is 1/2. I would recommend you so far to find C, be patient, put the numbers there and try to see what's going on. So y is equal to, of course, if you remember what I said, you really can use them. So C over B is the amount of shift. So if you don't mind, let me use that idea. Okay, amount the shift along the x direction. This is important to read. First, try to read the shift here on the picture. Forget about the formula on the board. Just think. Because this function is sine function, this should be compared with the original sine function. This is sum. This is one thing that you need to remember. The thing that I told you that draw the horizontal line, which I called it guideline. I don't know if that's the name for it or not. But what was the guideline? The guideline is y equals to 2. Yes? So you draw the y equals to 2 in your head. So exactly as before, so I draw that line. But be careful, I want to compare the blue one with the original sine function. What is the role of the guideline? The role of the guideline is to think about the guideline as your new x-axis. If you think in that way, how much is the shift? Look at the blue curve. Yes? No shift. Do you agree? Because this is the point that the blue curve intersects with the guideline. Yes? So there are no shifts. Do you understand that? So here, if you say this is the amount of shift, it is not correct because you are comparing it. This is your x-axis. If you want to do the same thing, your understanding is correct, but instead of doing it with the original x-axis, you have to do it with the guideline as your x-axis. Okay, so this is your guideline. Y equals to 2. Why is that? Because I told you, when you have D2, it means everything is shifted 2 units upward. So you can imagine that the x-axis is also shifted 2 units upward. Okay, so this new line is playing the role of your new x-axis. Okay, so let me just do it again. So I draw this new guideline. You need to think about the guideline as the new x-axis. Okay? And now when you have the new x-axis, I don't have any extra hand to show you here, but because when I leave it, so I can draw, by the way. So let me just draw it. Okay, so if I draw this, this is playing the role of your new x. Okay, now I was stupid thinking that I need another hand. Okay, anyway, but this one is actually the new intersection point. Do you see that? And the sine function exactly starts from the origin. So there is no shift. When there is no shift, what does it mean? Can you tell me what happens? The shift is 0. But on the other hand, what was the value for shift? Was c over b. B is some number, whatever, I don't care, but the fraction is supposed to be 0, so it means c is 0. Okay? So that is the graph of the function. Y is equal to a sine 1/2 x plus 2. If you draw the graph of this function, it will give you exactly that. Is that clear? Okay, now the question that I designed is probably the pinnacle of these questions. It's not probably very hard, that the idea is the same, but let me try to show you what.
Why?
No, forget about why. This is the problem that they have put forward. We want to solve it, yes?
Okay.
Yes? So what I'm saying is that, let me tell the main difference. The main difference, I haven't designed the question, by the way, yet. I am telling you, you see, I have written the function on top of its own graph here. Yes? And then I ask you to find A, B, C, and D for the green curve. And I haven't given you any information about these points. Yes? So is that clear? So you cannot say, for example, you cannot say I feel this is pi, or I feel this is pi over 2. There's no feeling there, yes? You cannot say this is 1. You cannot say this is 2. You have to find how much is one grid on the y direction, how much is one grid on the x direction. And then after you found that, then you can answer what are A, B, C, and D. Yes? Is that clear? So, I want to wait a little bit for you, because if you can really solve that problem, then you are on the safe side. So let me just repeat the question. This is the coordinate axis. I forgot to put this here. This is x-axis and this is y-axis. You see some grids, they are probably not with the same scaling, but we don't care about that. This is what it is. We know this is the rule of the red function. We also know that the green function takes this form, but there are 4 numbers missing. I want you to find these numbers exactly. And for the case of definiteness, everyone finds the smallest positive or negative value for C, okay? I just want to wait for you, because if you can solve this problem, you complete. By the way, this is also something similar to the one in the book. I pause recording and I wait for you. Is the strategy clear? Using the information from the red curve, you need to understand the scaling of the y and x axis. So we don't know how much is one grid on the x direction, we don't know how much is the one grid on the y direction. Using that information, first of all, you need to find these scales, these grids. And then the problem becomes the previous problem. You can momentarily forget about the red graph and just concentrate on the green graph and find A, B, C, and D with the trick that I just told you. So the only purpose of giving the red curve to you is to be able to use the red curve to fine-tune these grids. Yes? And I also, because I did it with GeoGebra myself, I have the function that I gave to GeoGebra to draw this. So if you have your answer, you can read it so that I can see it if you have done it right. Okay, let me solve the problem for you. Let us go back here. So the first thing that you need to understand is, so for example, how much is this grid? From here to here, we don't know. You cannot say this is 1. Be careful about that. If you say, I feel it should be 1, I don't care about your feelings actually. So you need to give me the correct answer. This is one grid, but there is no guarantee one grid is 1. Yes, might be a grid is 0.5 or might be 5. We need to understand that. How can I understand it? I would say that, okay, what is the amplitude of this according to the graph? Is from here to here. Yes, this is the maximum. So it contains how many grids? 2 grids on the y direction. Yes? But on the other hand, you know the amplitude from the function. What's the amplitude? 2. So now you are lucky. Each grid is 1. But if you just guess, it might be wrong. Yes? So you see, from here to here is the amplitude of this function. And the amplitude of the function is 2. So this means each grid is 1 unit. So let me just write it down here. So this is 1, this is 2. So it means that that's 1, 2, and 3. So now the important thing here is to understand how much is one grid on the x direction. How should I answer this question? From the period of my function. Yes? I should answer it using the period. Okay, how can I answer that one? So what is the period? I hope that you agree with me that the period is this. Up to here. Yes? This is one single period. Do you agree or not? Okay. And then how many grids are in one period? 3 grids. 1, 2, and 3. Okay? So I calculate the period of this function. By the way, let me write it here on my Google iPad. Okay? So what is the period of that function? From the formula, this becomes 2 pi over b. I am talking, so let me write with red, representing red. Yes? So t is 2 pi over b. So t is equal to how much? Is 2 pi. What is b in this problem with the red graph? 4. So this means t is how much? Is pi over 2. This is the period. But you just realized, you just told me that the period contains 3 grids. Yes? So what is the length of one grid? What is that? I have to divide pi over 2, which is the full period, by 3. So I divide pi over 2 by 3. The answer is pi over 6. So this is, if I ask you how much is here, you would say it is pi over 6. Yes? And for example, how much is here? Is 2 times pi over 6, which is pi over 3, and etc. But I don't need that. Okay, now I found the scaling of my graph. Now that I know the scaling of my graph, everything is ready for me to go and answer the question for that point. So let me just write it here, it's easier. So I would say that now, can you tell me for the green graph, so what is y max? Now it is clear, the y max is this, and this is 1 unit, yes, because we realize that the grids on the y-axis are 1 by 1. So this is 1 unit, but down. So y max is how much? Minus 1. What is y mean? Y mean is this value. 1, 2, 3, 4, 5, 6, 7. It's minus 7. Understandable? So y mean is minus 7. And then let me write from here. A is y max minus y mean divided by 2. So y max is minus 1 minus minus 7 divided by 2. It becomes 6 over 2. It becomes 3. So A is 3. Okay, and then what is D? D is y max plus y mean divided by 2. What is the answer? Yeah, minus 1 plus minus 7 divided by 2, which is minus 4. So D is minus 4. This is D. Okay, so we found A and we found D. Now time is for B. B is related to the period of the function. So what is the period here?
Pi over 6?
No, that's also a little bit tricky.
Wasn't it pi over 2?
Yes, what is that?
The green period like 2 period of the red.
So how do you know that? So the period you need to understand. So this is half a period. Yes? Do you agree? This is half a period and it contains the same, yes, Abdullah, so you are right. This half a period contains 3 grids. Yes? So the full period is 6 grids. Yes or no?
Yes.
Okay. Each grid was pi over 6. So the period is how much? Pi. On the one hand. On the other hand, it is supposed to be equal to 2 pi plus 2 pi over b. So what is b now?
Pi.
B is no,
2.
2. So 3 of them, we found them simply. And then we need to find the last one, which is C. Okay, but you need to compare how much is the shift. I told you, what is the idea? The idea is to draw a new guideline. What is the new guideline? Y equals to minus 4. So I draw the new axis, which will play the role of the new axis. Where is minus 4, minus 1, minus 2, minus 3, minus 4? So I have to draw this line, yes? So let me just draw it. Yes, good. So this is the new x-axis. You can pretend that this is the new x-axis. Yes? Okay. And then because this function is to be supposed to be sine function, compare it with the standard sine function. So the standard sine function starts from the origin, but this function has started from this point. So how much? This is the amount of shift,
Pi over 6.
so which is pi over 6. Yes, but to the left. And then amount of shift, do you remember what was the formula? It is C over B. It is equal to 1 pi over 6. Yes? But we already found B. B is 2 equals to pi over 6. So then it means that C is how much? Is pi over 3.
Oh, my C was actually right.
Okay?
It was pi over 3.
No, but your answer was wrong because of D, you told me.
Sure.
You- But then I didn't listen to you
Okay, but-
because you told me that my answer is the same.
No, I think we're only talking about that one. The only
Okay, so that was my mistake, sorry.
No, no.
But that is, so, but these are the numbers actually, okay? Yes, because I have the answer here. So here you see, finally y is equal to, a is 3, so this is the correct formula, 2x. By the way, I didn't explain, but I hope that you understand this should be positive, because the shift in this way was to the left. So it is 2 pi x, 3, yes, plus pi over 3 minus 4. But that is the actually function. So I don't think it is hard. So you see, I use the information of the red curve to understand the scales, and then the problem becomes the old problem, and then I use the scales to find the A, B, C, and D. Yeah, okay. So I think if we go to GeoGebra now, yes, that was the actually one that I drew. So you see, you can see on the right hand side, yes, on the left hand side. So that was the f function. The green function is 3 times c sine 2x plus pi over 3. By the way, you can make a lot of exercises yourself, yes? You can just draw the graph and then see that you can find those values, yes? Yes?
How do you calculate the correlation between this this graph and the normal one, like with these weird rectangles? Like, what is the correspondence? Like,
No, if you want, I can show you here. Well, I didn't probably understand your question exactly.
I want to know if there would be numbers on this grid. Will it be 1, 2, 3, or will
Yeah,
it be
you see
1.1?
that now. No, but we found that.
We found it. It was like
Yeah, these are the numbers. So I hide the numbers when I wanted to print this, but now these are the numbers.
That's exactly what I wanted to see. And what does it say?
Ah, you don't see that. Okay.
Very small numbers.
So what can I do? Control.
Yes.
Can you see that now?
Even smaller. Yes.
I think these stay the same size.
Yeah, the numbers remain the same size, so it doesn't matter.
Jose, the pi over 6 pad.
Wait there, radians.
These are, okay, I decide them to be radians. By the way, when you want to draw the graphing, so I change the distance because the default distance are 1 pi and pi over 2, but I change it to pi over 6 myself so that I can be able to do that. And this is, by the way, correct because pi over 6 and 1 are different, so they should look different in size. But by the way, this is not important. They might draw the grids exactly the same, but they are saying different numbers. This is also possible. So don't think about it in this way. If this is 1 unit on the x-axis, this should be also 1 unit on the y-axis. No. Actually, the one in the book was different, as you saw. The one in the book, the scaling on the x direction was different from the scaling on the y direction, but they were actually squares. That was probably, I'm not saying it's wrong, but this is more natural now. Yes, that was not natural, but still that's also correct. So this is why do not count on your intuitions and feelings, okay? So you should calculate things decisively here. Okay, any questions? Okay, thank you very much.